Hello and welcome to section 6.4 on cofactor expansion and the general definition of the determinant. The goal of this section is to study the general definition of the determinant and to compute the determinant of some special matrices. In section 6.2 we learned to calculate the determinants of n by n matrices for small matrices, n less than or equal to 3. The goal of this section is to define the determinant for an n by n matrix for any n. And we're going to use this using a technique called cofactor expansion. We can't do cofactor expansion until we know what cofactors are, however. And so we're going to start by learning what they are, and to learn what a cofactor is, we have to start by learning what a minor is. So 6.4.1, minors and cofactors. Definition 6.4.1. Let A be an n by n matrix with n greater than 1. Mij, the ij minor of A, is the determinant. It is the determinant of the n minus 1 by n minus 1 matrix obtained by deleting the ith row and the jth column of A. So we have a smaller matrix. We take its determinant, that is the minor, and if the minor is a determinant, that means Mij is a scalar. So very strange operation here, deleting rows and columns. Let's go and look at example 6.4.1 to see what that gives us. So suppose that A is this matrix here, 3 by 3, and B is this matrix here, which is a 4 by 4. We're asked to find M21 and M33 of A, as well as the 3,4 minor of B. So let's start with A. So M21 is going to be a determinant. So I'll write some determinant bars, and we are supposed to delete 2 and 1. Always in the order row and column, the ith row and jth column. So I'm supposed to delete the second row and the first column. If I delete the second row and the first column of A, well then I'm left with a 2 by 2 matrix, a 2 by 2 matrix that has these entries here. So I'm going to put those into my determinant, minus 2, 4, 3, minus 1, and notice that we had a 3 by 3, and now we're down to a 2 by 2, n minus 1. So if we take the determinant, we can do this now by our little cross your heart motion, so we know we're doing our down product minus our up product. So we have 2 minus 12, or minus 10. So M21, the 2,1 minor of A, is minus 10. M33 of A, so again, it's a determinant. We're going to delete this time the third row and the third column. If we delete the third row and the third column, we're left with this little matrix here, and so that is going to be the 2 by 2 that we take as our minor, 1 minus 2, 0, 1. And that is a super easy determinant to calculate. We have 1 minus 0, or just 1. So M33, the 3,3 minor of A, is 1. And then lastly, we're asked to calculate the 3,4 minor of B, so M34 of B this time as opposed to of A, and that also is a determinant, but we had a 4 by 4 matrix for B. And so if we're deleting one row and one column, if we're deleting the third row and the fourth column, so delete the third row and the fourth column, then what's left is going to be a 3 by 3, a 3 by 3 matrix that has these entries here. So our smaller matrix is going to be 3, 1, 0, 1, 0, 1, and minus 1, 2, minus 5. A 3 by 3 determinant we know how to calculate already. So we're going to recopy the first two columns and do our basket weaving, our triple down product minus up product method. And so we're going to get 0, minus 1, and 0, minus the other direction, 0, 6, minus 5. There's a plus in there. So we have minus 1, minus 6, so 6 minus 1 and minus 1, and we have minus 2. So the 3,4 minor, M34 of B, is minus 2. So that's what minors are. That's how you calculate them. What are they good for? Well, tune in next time in the next video and we'll look at cofactors and build up to an expansion using these cofactors.